We are going to explain and explore about laws of motion. Yes, let me check, is it working or not? Yes, it is working. So in this slide, in this lecture, we have lecture which name is laws of motion. Yes, you will observe what motions, uh, acting of motion. Okay, something is in rest or in motion, all about this. So here, motion. So laws. What is meaning of laws? Rules, you can say. Rules of motion, properties of motion. Okay, properties of motion. But uh, rather than saying properties of motion, here we are understanding what laws of motion. That's why slightly will be little from properties of motion. So it is a laws of motion. Clear? So here it is important to know you what is it, what is this lecture saying, name of this lecture, what is it trying to explain. It is telling you you are going to understand laws of motion. Okay, slightly little bit information regarding about rest of an object we will understand, but our whole focus, our entire focus will be on discussion of motion. Okay, motion. Clear? In this lecture, inertia will come, Newton's law will come. Yes. So overall, object will be moving. Object will be moving. So how is object acting? We will see. Why is it moving? Why is object in motion? This is also a question. There are some questions in this which will feel to us that what is the reason behind moving this object. So, got it? Laws of motion. Yes, it is a law of of this motion. Then it will happen. I would like to move on towards this slide. Let's start from second slide. Force. We are starting from force. It is also a separate chapter, but it came in this lecture because a connection of this force is with laws of motion chapter. That's why I take it. I will feel you. I will make you feel. I will make you feel. Don't worry. Force. Okay. From basic, let me explain meaning of force. Here, look. It is just a pull or push. Okay. In our daily life, what do we do in our daily life? We push something, we push something, we pull something. There are a lot of objects that are being pulled, that are being pushed. Are you understanding? So here, when we push object, then that object will come into motion. Position of that object will be changed when when we will apply force. Either we can push or pull. Clear? This happens in a real life. It is happening in nature. Without force, anything cannot be moved, and there are a lot of things that are moved by applying force. Clear? So definition of a force is just what it is, just a pull or push. Here you can see this is book language. A force is a push or pull upon an object resulting from its interaction with another object. This is a book language. From our language, what can be understood from this? This first sentence, which is a definition of a force, is trying to tell us that any object, when object will be moved by applying force, either either person will be pulling, person will be pushing. So that object will move. When that object will move, then it will cover distance. It will it will tell you position of that object. Where was initial position of an object, and where is current position of that object. If there is any change of an object after applying force, then we can say we applied force. We applied force. Clear? And when it comes to force, then right now we understood meaning of force. Towards it, we will see what types of force, which is very compulsory to understand. When it comes to types of a force, then there are two types of force. One contact force and second uncontact force, without a touching force. Here you will be surprised. Okay, we now contact force, but what is uncontact force? Before we move on this, let's complete this slide. The state of motion of an object. Yes, it is telling you when force will be applied, then state of motion of an object will be changed, and it will happen when force will be applied on that object. Clear? If a person is pushing an object, it means there is a motion of that object. If a person is pulling that object, still there will be motion of that object. Clear? Now the shape of an object. The shape of an object. Okay. Right now ignore it. I will explain about it later. Here you can see push. These are what types of types of force. But push or pull, it is what meaning of a force. Here magnetism, gravity, friction, acceleration, gravity, magnetism. These are types of a force. Now from this figure, I can explain types of a force. It is a pushing. It means it is applying force. It is a pulling. This person is pulling this object. It is also force. Magnetism, which is uncontact. Now understand what is a uncontact force. Anything which is not contact with other object. Okay, if you didn't understand, then let me explain. First of all, about contact force. Here contact, which means a object will be contact with another object. The object is the contact with the other object. For example, for example, I have a book. This is a book. Okay, this is a book, and here I will push like this. What is happening? Something position of this book is changing. Clear? So here I applied force, but this is also object. We can consider you can consider my hand as object. So here it moved because of we applied force by using my hand, and contact of this hand was was with contact of this book. So this came in contact of this with contact of this object. That's why it moved. It moved. Clear? So a object will be moved. A object can be moved by applying force with another object. With another object. Okay. Now what about uncontact? Uncontact. In the case of uncontact force, something crazy will happen. You can say force will be invisible. Force will be invisible. Because here we are understanding what uncontact force. Uncontact force. So a object will move, but another object is not another object is not being another object is not being used. Or contact of another object is not with the contact of first object. Okay. For example, magnets. Just put a magnet here and put in your hand what magnetic material. For example, iron. Iron. Okay. What will happen? And bring both together near, not too much near, but little bit. Now what will happen? This magnet will attract this iron material, but here contact of this iron was not with the contact of this magnet. So it is a nature, and here force was invisible. Force was invisible. It will happen with magnets. Clear? What about gravity? Gravity. It is also force, but again, I would say what it is invisible force. Invisible force. Something will be thrown upward, and when velocity on the top will be zero, then that object will fall down. So this object came into motion. Came into motion. So did we apply what? You can take an example of apple or another fruit. An apple is a contact of a branch of the tree. After a few days, that apple fall down. That apple fall down. So how did apple come into motion? With contact of a branch, it was erased, but after few days, it came into motion. But nobody applied uh, external force. So here you would say it happened because of a gravity force. Clear? Yes, this is the reason. So anything which is coming from a sky, then that force will be known as gravitational force. Clear? What about the friction force? What about? It is just opposite force. Okay, it is just opposite force. A object is being moved like this. A object is moved like this, like this. Friction will happen when we will have two objects, and here this one there are two objects, and I moved my upper hand like this, and it is with contact of this object is with contact of this hand. That's why, and whatever you are observing, rubbing of these two hands is a friction. Friction is less or more, it will depend on what is the nature of a surface of that object. If object surface of the object is rough, then friction will be more. If mm, surface of the object is very plain, then that object friction of that object will be very less. Clear? Work of a friction is to stop, is to block the object. You can understand. When a object moves forward, then a ground is another object, and a cycle is a second object, and cycle is moving. So here a road is applying opposite force to the cycle, to the cycle. Road is stopping the cycle, but person is applying force by moving by using paddle of the cycle. So there are two objects. One is a cycle, second is a road. Road is blocking the object, and object cycle is applying force forward, but road is uh, stopping opposite side, towards the opposite side. Clear? Now let me move towards types of force. I was explaining about it right now. Balanced force. Balanced force, balance one side, second side between is equal. If in one side is 60 Newton, then another side should be equal 60 Newton. Then we would say forces are balanced. Yes. Is it explanation of balanced force? Yes. When it will come to balanced force, then do not change the state of motion. Yes. Hold on. If this side is 16 and this side is also 16, so uh, will object move? No. because of forces are equal. Forces are equal. Clear? There are two persons in this side. In this side, there are two persons, and this side there are three persons. This two person, this two person are applying force of 19 of 20 Newton, and this three person, this three person are applying same 20 Newton force. What will happen? What will happen? So here we will not care about how much are there people. We will not care about. We will care how much are newtons, how much forces are being applied. This is what we will care. This is what we will focus. Okay. So two persons are applying force of 20 newtons, and this side three persons are applying 20 newtons force. Both are same. So that's why if both sides are equal, then what will happen? State of object will not change at all because of both sides are equal. That's why object will not move. What if this side there are three persons and this side there are two persons? Here this third person applied more force after few seconds, after few minutes. So let's say Newton is in this side is how much? 25, and this side is how much? 20 newtons. Now what will happen? Would you say that this person will apply, these persons are applying more force as compared to this person? And here, because here object this two persons will move, backward, because newtons of this Newton of these two persons is a less than the these persons. That's why this two persons will move backward, and this three persons will move forward. So a side has more balance, more force, then this side will move forward. A side has less force, less Newton, then this side will move backward. Clear? It will happen when one side has a more force. Now what I'm trying to tell you, I am trying to tell you both sides Newtons both sides are same, then it will be considered as balanced force. Motion will not move change at all. Motion what I am saying, object will not move at all because of both sides are equal. If both sides are not equal, one side in one side people are applying more force, and in another side people are applying less force. So people who are applying less force will move backward. it will happen. It is happening because of forces are unbalanced. That's why. Clear? Contact forces. Contact forces. Contact forces and contact no. Non-contact forces. I explained in previous slide, but still I will repeat it again. In book language, here is given what applied through physical contact. Yes, yes, it is a standard meaning. A standard meaning. In our language, we can explain it, but the meaning should be same. We are explaining contact forces in our language, then meaning should be same. Explanation can be different. So it is telling you whatever type of forces are being applied on this object, but it will happen with the physical contact. For example, muscular force, friction. These are these are physical contact. This is when we apply our parts, when parts of a human is applied as a force, then that force will be considered as muscular force. Clear? We are applying a force by using another object. So contact of this object should be physical contact with another object. Then this kind of object is will be considered as contact forces. What about non-contact forces? Act without contact. That's it. Yes. Participation of another object will not be with the contact of a first object. A object will move without any contact of another object will be considered as non-contact forces. For instance, gravitational, magnetic, electrostatic. In these forces, anybody will realize that another object is not being applied, another object is not being used to apply force on first object, which is moving, which will be moving. Yeah, it happens in nature, it is happening in nature. What is the physics? Physics is a study of nature, isn't it? Whatever is happening in nature, not all things, whatever is happening by nature, in nature, is study in physics subject. Clear? Physics tells what a reality of nature. This is what is work of this object. This is how it works. Rules we identify, rules we find, laws we find, properties of a reflection of light we find. Okay. Let's come on the point. This slide is clear here. This figure, this figure. Yeah. This figure is an example of a balanced force. In this side, there are how much people? Two to four. There are four peoples. In this side, there are same four people. But here we don't have given newtons. This figure is telling you this side there are four, and this side there are four people same. So in both side people are same, number of people are same in both side, as we studied that if newtons in both sides are same, that force is balanced force. Clear? In this case, what is happening here? This girl is applying a force of 6 Newton, and this boy is applying a force of 10 Newton, and both are pulling, not pushing. So I told you force meaning of force is what? Just push or pull. Both are pulling, and boy is pulling with a force of 10 Newton, and girl is pulling uh, with a force of 6 Newton. Which is more? Wo one is pulling with more Newton, you would say. Mm, he is he is applying more force, more Newton. Now tell me, who will move backward and who will move forward? So of course, she is applying less Newton, so it will move what? It will move backward. It will move backward, and he is applying more force. He will move backward. Now I said that if a person is applying more force, then he will be moving backward. But in this figure, what is happening? This guys, this boy is applying too much force, more force, but he is moving backward. Why is that? Because of both are pulling. Okay, both are pulling. That's why when two objects are pulling a object and force is unbalanced, then what will happen? A side which has more Newton will move backward, and another side which has less Newton will move forward. It will happen when a object is being pulled. Then clear? In the case of pushing an object, two objects are pushing the third object. So in this case, one side which has what? More Newton will move will move forward, and another side which has less Newton will move backward. It will happen when object is being pushed. Then clear? Shall we move towards this slide? Newton's law of motion. First law, we came on the main discussion of the lecture. Newton's laws of motion. Is your mind thinking something when you heard this phrase, Newton's law of motion? Is your mind thinking something Okay, let's start from here. First law of motion is also known as the law of inertia. Law of inertia. An object remains in its state of rest or uniform motion unless acted upon by external unbalanced force. So first law of motion is what? First law of motion. Newton's first law of motion is that a object is in rest, still in front of me. There are a lot of objects. In front of me, there are a lot of objects which are in rest, which are in rest. Nobody is applying, nobody is going to apply force on these objects which are in rest. Now what will happen? Now what will happen? Object will be in rest still, because force is force is not being applied. That's why objects will be in rest. But what if okay, what if I am going to apply force on the object which is in rest? For example, in front of me, uh, this is a book. Okay, this is a book. In front of me is a book. I'm going to apply force. What will happen? This is already in rest. This object is in rest. It is what it is a first law of motion. The first law of motion says, explains that it will be in a rest. Object which is in rest will be in a rest until unless external force will be applied on that object, on that. Okay, I just said what, there are a lot of objects which are in front of me are in rest. So this is law. Try to understand. This is law. It is a nature. We cannot change this this first law of motion. This first law of this Newton's first law of motion. I know object is not moving. I know. But complete complete explanation of law first law of motion is what? A object is in rest, and when external force will be applied on object which is in rest will come into motion. This is a complete explanation of first law of motion. Clear? So first law of motion is what? There are a lot of objects which will be in rest if external force is applied, then that object will come into motion. Clear? A object is moving with constant speed. A object is moving with constant speed, and this object and this first law of motion say that this object which is moving with a constant speed will move in constant speed until unless external force will be applied on moving object. So what will happen when we will apply an external force on moving object? Now what will happen? Two things will happen. I think three things will happen with a moving object when external force will be applied. A object is moving with constant speed is coming to you. Is coming to you. Now here, object can be stopped by applying external force. This is the first thing which will happen when external force will be applied on moving object. Isn't it? Tell me. Yes. What about another thing which can happen? So another thing can happen is that if object is coming, a object is moving, can moving object can be accelerated. Means a speed of an object is constant, can be increased by applying external force. Yes, it happens. It happens in nature. It is happening in nature. In first, in first we saw that object can be stopped, but in the second case we are looking what we are saying that object can be a speed of a moving object can be increased. If I am saying a speed of moving object can be increased and it increased uh, due to applying force. Now, if object a speed of object can be increased, it means it can be decreased. It can be and decreased by applying external force. All this is happening because of an external force. Because of an external force. Clear? Now, what does inertia of law of inertia says? It explains the tendency of an object to resist a change in its state of motion. Same explanation of law of inertia will be same as we saw explanation of first Newton's first law of motion. Law of inertia, it can be classified into three types. First, uh, I think inertia of rest, inertia of motion, inertia of direction. I will come to the explain of to the explanation of uh, law of inertia. Don't worry, I will explain. A book on a table stays at rest until pushed. Yes, here. Hold on. This is a what? This is a book which is in front of you. It is in a rest. It is not moving at all. Now I am going to move it like this. I want to remove this in from here. So it came in motion. It was in rest. It stays in rest. But when I applied external force, it was removed. It was removed because of external force. External force you will hear a lot of time. Okay. So a moving car stops when brakes are applied, and here brakes are external force. Brakes are external force. When brakes are applied, then car will stop. So where is external force? Brake is external force. We applied force by using brake, isn't it? So these were two examples. Second law of motion. Second law of motion. Remember, from first law of motion, we understand what? Uh, we understand that object is moving or not. What is the nature? Yes, it will know. Object is moving or not. From second law, we observe what we do calculation from second law of motion. We calculate how much forces were applied on object. It is studied in second law of motion, and in first law of motion is studied what? Force is acting. Force is being act. Clear? The rate of a change of momentum of an object is directly proportional to the applied unbalanced force and takes place in the direction of the force formula. It is telling you from figure, try to understand if you are not understanding this. Notice, the force acting on a moving object is a product of the mass and acceleration. If mass of an object which is being pushed or pulled is a more is a more, so here of course force we need to apply force more if mass of an object is more. Then if mass of an object is less, then we need to apply less force. According to need, you will have to apply force. You will apply force how much? It will depend on mass of the object. Yes, that's why definition is saying, definition of explanation of a second law of motion is saying directly proportional to the applied unbalanced force. Means mass of an object will be more, then force will be applied more. If mass of the object is less, then force will be less. Clear? Clear? Here a word you can see, acceleration. What is acceleration? Acceleration explains what? A speed of an object. It is increasing or decreasing. Object will decrease or increase. Will acceleration will explain. Acceleration will explain. Clear? A heavier object requires more force to accelerate. Yes. If you are pushing a object and you want to apply accelerator, you want to apply accelerator, then what will happen? A speed of that object will increase when you will increase when you will increase a newton, then a speed of that object will increase. Clear? Kicking a football harder increase its acceleration. Yes, if you apply more force and object mass of object is less than that object, if that object will come into high motion. Clear? Third law of motion, it will tell you nature of motion. We will take action and you will get reaction. You will take action, you will get reaction. For every action, there is a equal and opposite reaction. Action and reaction forces act on different body. Example: a gun recoils when a bullet is fired. A swimmer pushes water backward to the forward. When you walk, then what happens with your leg? You apply what? A force. Then you get what? A result. Opposite force you get. It will tell you just the nature of motion. Third law is what? Action or reaction. You will take action, then you will get a reaction. Momentum, defined as the product of mass and velocity. Now tell me, you can say it is also impact. Impact is high or more, high or less. If mass of the product is more and velocity is also more, what will happen? Impact will be normal. Impact will be normal when that object will come in contact of another object. Now, what about if mass of an object is less and velocity of that object is very high? What will happen? Impact will be high. You will see a you will see a view. Impact will be high. Clear? P is represented as a momentum and mass will be represented as a velocity will be represented as V. Clear? From given figure you can understand mass multiple velocity momentum. Yes, it is a formula. So this person is running with this much speed and weight of this person is 90 kg. 90 kg. What will happen? Okay, this is a momentum. This is how momentum is calculated. So now mass increased of this person and speed is the same. This is happening. This is calculation of this happening motion. Here you can see this is a object. This is also object. This object is going to this direction, means it is going to hit this object. So now what will happen? You will get momentum in positive. When it will go this side and this side, there are two objects, it is going this side, it is going this side. What will happen? Momentum will be in negative. Clear? Unit of mass is always what? Kg, because whatever we measure a solid material in kg. Okay, velocity is measured in meter per second, it is a unit. Momentum we have in momentum what? Mass and velocity. So for mass I think kg, and for velocity meter per second, so kg meter per second. This is a unit for momentum. Law of conservation of momentum. Total momentum for two objects before and after collision remains the same, provided no external force acts. I am ignoring it. I will explain later. We have some questions. Force is what? Push or pull. Newton's first law is also called law of inertia. Yes, one thing is like law of inertia are classified into three types: law of rest, inertia law, um, rest, inertia of rest, inertia of motion, inertia of direction. Look, inertia of rest explains by saying object is in rest, will be in rest until unless it will be external force will be applied on object which is in rest, will be in rest. Clear? Second, mm, inertia of motion. A object is moving in motion, will be move continue. But when an external force will be applied on another object, when an external force will be applied on another on moving object, then what will happen? That object will come, speed of that moving object will increase or decrease. Clear? Direction. A object is moving in a direction, in a direction, so direction will be same. If a object is moving in circular shape, so this object will be moved in circular shape when, until unless an external force will be applied. Okay, when an external force will come to apply on moving object which is in one direction, which is moving in one direction, can be can be turned into another direction by applying an external force. Clear? Okay. SI unit of force is also Newton. It is what written in mathematics as, it is represented as a Newton. Force is represented as a Newton. SI unit of force is a Newton. Clear? Momentum is defined as P is equal to m. Action and reaction forces act on the a force can change the speed of an object. A force can change the speed of, yes, of an object. A moving object continues to move unless acted upon by an. The formula force is the formula for force is what? As you know, F is equal to ma, where F is force, m is momentum, and a is acceleration. Friction is a type of opposite force. It is the external force. It is the opposite force, yes, isn't it? Next, subjective questions. Define force. So, as we know, it is just a push or pull. What are its effects? Effects are it can increase the speed of moving object, or it can also decrease. It can also decrease the speed of moving object. It can stop the moving object. It can bring the object which is in rest into motion. Okay, into motion. These are effects of force. Uh, Remember, it cannot change the mass of an object. State and explain Newton's first law. State and explain Newton's first law of motion with example. Simple. A object is in a rest because there are a lot of objects in surrounding us which are in rest will be in a rest. If external force are applied, external forces applied object on objects which are in rest will come into motion. Clear? And if a object is moving, so that object will be moved. Clear? Uh, Examples. For example, a car is moving with constant speed, will be moving in constant speed. But when external force will come into role, then what will happen? Something will happen. What is inertia? On what factors does it depend? Inertia is just what? Laziness. Laziness. Drive the formula F is equal to ma from Newton's second law. As you know, acceleration is what? Final speed minus initial speed upon t upon t. As it clear. That is how you can drive the formula F is equal to ma. Explain Newton's third law with two examples. With Newton's third law, okay, it shows what nature of the uh, motion, nature of the motion. Newton's third law represents. Clear? You have to give two examples of fifth question. Next slide. You have five more questions in front of you. Define momentum. It gives you impact. If velocity is high and mass is low, then impact will be more. If mass is more and velocity is less, then what will happen? Speed of this object will be less. State and prove the law of conservation of momentum. This is for you. Differentiate between balanced and unbalanced force. Balanced force, if forces are balanced, then object will not move, and if forces are unbalanced, then object will move. Either it will move backward or forward. Okay, forward. Why does a gun recoil when a bullet is fired? Because of it when it takes action, then it provides a reaction. That's why it happens due to Newton's third law of motion. A cricket player lowers his hands while catching a ball. Why? Because cricket player knows that when ball will come, then I will catch that ball by moving gradually my hand backward, so that ball can come into my hand, and I will not get hurt while catching the ball. That's why that's why cricketer player uh, brings his hand backward gradually according to requirement. A heavier object requires more force to accelerate. Explain why. A heavier object requires more force to accelerate. Yes, object. Yes, it depends. If a object needs more acceleration, it means mass of the object is high, and we saw that any object which mass is very high will demand what? More acceleration. Clear? the end. That's all. uh, in next lecture we will see something else chapter. For now, that's all.